Hello, and welcome to section 11.2, Fractional Exponents. In this section, we will be simplifying expressions that have fractions in the exponents. Before we start, here I have for you a table with numbers raised to different exponents and their results. In the first column, we have numbers raised to the second power. In the second column, numbers that are raised to the third power. And then in column 3, numbers that are raised to the fourth power, and so on. On many of the problems we will see in this section, we will be working with numbers from this table, so it would be a good idea to write them down and have them handy when we do the problems. Now, from each of the columns, I picked an example, and we will discuss each of these examples individually. From the first column, I picked 4 to the second power equals 16. 4 to the second power is an exponential expression, and the exponent is 2. The result of this exponential expression is 16. Now, to undo this operation and to find what number was raised to the power of 2 to get 16, we use the radical symbol. And we write square root of 16 equals 4. So what we have here is a square root. From the second column, I picked 5 to the power of 3 equals 125. So if we multiply 5 3 times, 5 times 5 times 5, we will get 125. In this exponential expression, 3 is the exponent and 125 is the result. Now, to undo this operation and to find what number was raised to the power of 3 to get 125, we use the cube root, or the third root. And we say that the third root of 125 equals 5. So again, we call this the third root or the cube root. Now, if in this expression 5 to the power of 3 is the exponent, in this radical below, this 3 is called the index. In the next column, we have 3 to the power of 4 equals 81. So if we multiply 3 times 3 times 3 times 3, we will get 81. In this expression, 4 is called the exponent. Now, to undo this operation and to find what number was raised to the power of 4 to get 81, we use fourth root. So what we have here is fourth root of 81 equals 3. If above 4 is called the exponent, below 4 is called the index. We have two more examples to discuss. And here we have 2 to the power of 5 equals 32, and in this expression, 5 is the exponent. To undo this operation, we use the fifth root of 32, which equals 2. And this index 5 tells us that we are looking for a number that would be raised to the power of 5, and we would get 32. So again, this 5 is called the index. And in the last example, we have 2 to the power of 6 equals 64. 6 is the exponent. And to undo this operation, we use the sixth root of 64, which equals 2. And here, this number 6 is called the index. So here we have 5 examples of radicals, and in the last one, the index is 6. In this one, the index is 5, then we have index 4, then we have the index of 3, and in the first example, the index will be 2. When the index is 2, we usually don't write it, so each time you don't see an index, just remember that the index is 2. And if it helps, you can write that the index is 2. Now, if here we discussed examples with radicals that have just numbers, in the next examples, we will discuss about radicals that have variables. In the first example, we have to find the square root of x to the power of 10. The index of this radical is the invisible 2. This tells us that we are looking for an expression that we will raise to the power of 2, and we will get x to the power of 10. So let's think about this. We need an expression that we would raise to the power of 2, and we would get x to the power of 10. This expression will be x to the power of 5, because if we multiply the exponents 2 and 5, we will get 10. So then, we can say that the square root of x to the power of 10 is x to the power of 5. In the next example, we have cube root of x to the power of 12. So the question is, what expression we would raise to the power of 3 and we would get x to the power of 12? This would be x to the power of 4, because 4 times 3 makes 12. Then we can say that the cube root of x to the power of 12 is x to the power of 4. Now let's see another example. Down here we have the fifth root of x to the power of 35. And because the index is 5, we need to find an expression that we would raise to the power of 5 and we would get x to the power of 35. This expression would be x to the power of 7, because 7 times 5 is 35. So then, the fifth root of x to the power of 35 is x to the power of 7. Now, do you see how in each of these examples I did some work to the right side to understand what the answer would be? However, we can also get the answer just by dividing the exponent by the index. For example, in the last radical, the exponent for x is 35 and the index is 5. If we divide 35 by 5, we will get the exponent 7. In the example above, the exponent of x is 12 and the index is 3, and 12 divided by 3 will give us 4. And in the first example, the exponent is 10 and the index is the invisible 2, and 10 divided by 2 will give us the new exponent 5. So, as you see, in all these examples we have radicals, and in each of these radicals we have x inside with an exponent. To write each of these radicals in exponential form, we just have to divide the exponent by the index. Now, let's continue with more examples. In the next example, we have the seventh root of x to the power of 5. We will write this radical expression in exponential form. When we divide 5 by 7, we will not get a whole number. Instead, the result will have an exponent that will be a fraction, 5 over 7. In the next example, we are given fifth root of x. In this example, x has exponent 1 and the index is 5. When we write it in exponential form, we will have x to the power of 1 over 5. Again, as you see, we divided the exponent by the index. Here we have one more example, and this is square root of x. In this example, x has exponent 1 and the index is 2. Therefore, the exponential expression will be x to the power of 1 over 2. Now here we have the following rule. A to the power of 1 over n equals nth root of a. Indeed, if this a has exponent 1, then 1 divided by n will give us the exponent 1 over n. Let's see a few examples. X to the power of 1 over 4 equals fourth root of x. So if this x has exponent 1, then 1 divided by 4 will give us the exponent 1 over 4. Another example would be a to the power of 1 over 7 equals seventh root of a. And one more example, 25 to the power of 1 over 2 equals square root of 25. Indeed, 25 has exponent 1 and the index of this radical is 2. So the exponent here is 1 over 2. We can also evaluate this expression, and we know that square root of 25 is 5. So remember that when we have a number with the exponent 1/2, that means we have the square root of that number. Now let's see another rule. Here we have a to the power of m over n equals nth root of a to the power of m, or this equals to nth root of a all to the power of m. So this rule tells us that we can write a to the power of m over n as this expression or as this one. So here to the left we can write a to the power of m over n as nth root of a to m, And to the right, we can write a to the power of m over n as nth root of a all to the power of m. Let's see how these rules can be applied on an example. Let's say we have to evaluate 8 to the power of 2 over 3. First, we will rewrite this exponential expression in radical form using this rule. For this, we will start a radical and we will place 8 inside. Then the numerator of this fraction will go to the exponent and the denominator will go to the index. So we will have cube root of 8 to the power of 2. Now 8 to the power of 2 is 64, so now we have cube root of 64. And now what number do we raise to the power of 3 and we get 64? That will be 4. So the cube root of 64 equals 4. Now let's evaluate the same expression using the rule to the right. Here we will start a parenthesis with the radical symbol and 8 placed inside. Then the number 2 in the numerator will be the exponent and the number 3 will be the index. So we will have the cube root of 8 all to the power of 2. So far, do you see the difference between this side and this side? Here the exponent 2 is inside the radical, but here the exponent 2 is outside of the radical. Now, once we have parentheses, we will evaluate the expression inside the parentheses first. Cube root of 8 is 2, because 2 to the power of 3 makes 8. And now we still have the exponent 2. Then 2 to the power of 2 will make 4. As you see, in both cases, we got the same answer. So, having this exponent 2 inside the radical or outside of the radical will give us the same answer. Now, let's see why these both ways are correct and they both give us the same answer. You see that initially we had 8 to the power of 2 over 3, and we can write this expression as 8 to the power of 2 all raised to the power of 1 over 3. Indeed, if we multiply 2 and 1/3, we will get 2/3. On the other hand, we can write 8 to the power of 2 over 3 as 8 to the power of 1 over 3, then all raised to the power of 2. In this case, if we multiply 1 over 3 and 2, that will also give us 2 over 3. In the first case, first we raised 8 to the power of 2 and we got 64, then we took the third root of 64. In the second case, first we found the third root of 8, which is 2, then we raised 2 to the second power and we got 4. Now the question is, should we do a problem like this using this formula or this one? Many times when we have numbers inside the radicals that we raise to exponents, we may end up with very large numbers inside the radicals. Now here we don't necessarily have a very large number, but if we would have a very large number, then it would be better to go with the second formula. Now let's see if we can apply all this knowledge on more examples. In the first example, we will be evaluating the expression 8 to the power of 1 over 3. For this, we will write 8 to the power of 1 over 3 in radical form. So we will start a radical, we will place 8 inside, and 8 will have the exponent 1, and the index will be 3. And now, what number raised to the power of 3 will get us 8? That will be 2. Now, when evaluating these types of expressions, it would be good to have that table we talked about in the beginning of this lesson. In this example, we will be evaluating negative 8 to the power of 5 over 3. As you see, this expression has a negative, but it doesn't have any parentheses. So we will keep this negative in front, and then we will convert 8 to the power of 5 over 3 to a radical form. So let's start a radical and place 8 inside, then the exponent will be 5 and the index will be 3. So remember that each time the numerator will be the exponent and the denominator will be the index. From here, if we raise 8 to the power of 5, it will give us a very large number. Therefore, we will rewrite this and we will start parentheses. We will have cube root of 8 inside and we will move the exponent 5 outside. Then let's bring down the negative, and inside the parentheses cube root of 8 is 2. So now we have 2 to the power of 5. This will be equal to negative 32 because 2 times 2 times 2 times 2 times 2 will be 32. So the final answer is negative 32. In this example, we will evaluate negative 32 to the power of negative 4 over 5. As you see, here we have a negative in front of the whole expression and a negative in the exponent. We will keep this negative that is in front of the expression, but to make the exponent positive, we will move 32 to this exponent down to the denominator and the exponent will become positive. So this will be equal to negative fraction 1 over 32 to the power of positive 4 over 5. Now in the denominator, we will convert this expression into radical form. So we will get negative 1 over, let's start a radical. Inside we will write 32 and the exponent will be 4 and the index will be 5. Now because 32 to the power of 4 will give us a very large number, let's rewrite this and have the exponent 4 outside. So inside the parentheses we will have the fifth root of 32, then all this will be raised to the power of 4. Now we know that fifth root of 32 equals 2, so now we have negative 1 over 2 to the power of 4, which will be equal to negative 1 over 16. And that is because 2 to the power of 4 equals 16. In this example, we will be evaluating 3 to the power of 10, all raised to the power of 3 over 5. Let's start by multiplying the exponents 10 and 3 over 5. Then we will have 3 to the power of 10 multiplied by 3 over 5. Let's divide both 10 and 5 by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. This will give us 3 to the power of 6, because 2 times 3 makes 6. And 3 to the power of 6 will be 729. Here we need to simplify the expression x to the power of 3 over 4 times x to the power of negative 2 over 3. We know that when we multiply two expressions that have the same base, then we just have to add the exponents. Then this will be equal to x to the power of 3 over 4 plus negative 2 over 3. To add these two exponents, we need to have the same denominator. Because the denominators are 4 and 3, the least common denominator will be 12. Therefore, we will multiply the numerator and the denominator of the first fraction by 3 and the numerator and the denominator of the second fraction by 4. Then we will have x to the power of 9 over 12 plus negative 8 over 12. This will be equal to x to the power of 1 over 12, because 9 over 12 minus 8 over 12 is 1 over 12, and this will be the final answer. In the next example, we will be simplifying 32, x to negative 3, y to negative 4, all raised to the power of 6 over 5. As you see, inside the parentheses, we have a product of three factors. We have a number, we have x, and we have y. Each of these factors will be raised to the power of 6 over 5. So then, this will be equal to 32 to the power of 6 over 5 times x to negative 3 raised to the power of 6 over 5, which is negative 3 times 6 over 5, and then times y to the power of 4 multiplied by 6 over 5. So you see that I multiplied negative 3 by 6 over 5, and then I multiplied 4 by 6 over 5. All this equals to 32 to the power of 6 over 5 multiplied by x, and now let's multiply the exponents. Negative 3 times 6 over 5 is negative 18 over 5. And for y, 4 times 16 is 24, and we will have 24 over 5. So remember that when you multiply a whole number by a fraction, you just multiply this number by the numerator and you keep the denominator the same. Now we have these three factors and we see that x has a negative exponent. Therefore, we will start a fraction and we will move x down. We also need to check if we could simplify this expression anymore. So I will start a fraction and I will bring x down and I will make the exponent positive. But in the numerator, let's write 32 to the power of 6 over 5 as the fifth root of 32 all to the power of 6. And next to it, let's bring down y to the power of 24 over 5. Now, fifth root of 32 makes 2, so here we will have 2 to the power of 6. Then all this equals to 2 to the power of 6 times y to the power of 24 over 5 over x to the power of 18 over 5. And 2 to the power of 6 makes 64. So all this will give us 64 y to the power of 24 over 5. All this divided by x to the power of 18 over 5. So as you see in this problem, we evaluated the expression that had numbers only, and we made sure that x and y have positive exponents only. This is the last example of this section, and here we will be dividing one expression by another one. Now recall division of fractions. When we divide two fractions, we multiply by the reciprocal of the second one. The same we will do here. We will convert this division into multiplication by flipping the second fraction. So then we will keep the first fraction as it is, 25 to the power of 1 over 2 x to the power of negative 1 over 4 over 27 to the power of 1 over 3 times y, and now we will multiply. And now let's flip the second fraction. In the numerator, we will write 3 to the power of negative 1, y to the power of 1 over 4, and in the denominator, we will write 5 to the power of negative 1, x to the power of 2 over 5. We can write 25 to the power of 1 over 2 as square root of 25, and then x to the power of negative 1 over 4. In the denominator, 27 to the power of 1 over 3 will be cube root of 27 multiplied by y. In the second fraction, 3 has a negative exponent, so we will move it down and the exponent will become positive, and 5 also has a negative exponent, so we will move it up and the exponent will become positive. Then in the second fraction, we will have 5 to positive 1, which is just 5, and then let's write y to the power of 1 over 4, and in the denominator we will have 3, and then x to the power of 2 over 5. Then square root of 25 is 5, x to the power of negative 1 over 4, over cube root of 27 is 3, y, and the second fraction we will bring down as it is. Now let's multiply these two fractions together. In the denominator, 5 times 5 will be 25, x to the power of negative 1/4, y to the power of 1/4. So then let's write 25, x to the power of negative 1/4, y to the power of 1/4. In the denominator, 3 times 3 is 9, then we have y and we have x to the power of 2 over 5. So let's write 9, and we can write x first to the power of 2 over 5, then y. Now in this fraction, in the numerator and in the denominator, we have numbers, we have x, and we have y. These two numbers cannot be reduced any further, so we will bring them down as they are, 25 over 9. But now, once we have x in the numerator and x in the denominator, we will subtract these two exponents. Then we will do the same with y. Then we will have x to the power of negative 1 over 4 minus 2 over 5, and y to the power of 1 over 4 minus 1. And this is because this y has exponent 1. In the exponents for x, the least common denominator will be 20. Therefore, in the first fraction, we will multiply the top and the bottom by 5, and in the second fraction, we will multiply the top and the bottom by 4. In the exponents for y, let's write 1 as 1 over 1. Then, to get the same denominator, we will multiply the top and the bottom by 4. Then we will have 25 over 9 x, and in the exponent we will have negative 5 over 20 minus 8 over 20. Then let's bring down y, and the exponent will be 1 over 4 minus 4 over 4. Let's continue from here. 25 over 9 x, and then negative 5 over 20 minus 8 over 20 makes negative 13 over 20. And let's bring down y, and 1/4 minus 4 over 4 is negative 3 over 4. Now we see that both x and y have negative exponents, so both of them have to go down next to 9, and their exponents will be positive. So let's start a fraction, and in the numerator we will just keep 25, but in the denominator we have 9, and now we will bring down x, and the exponent will become positive 13 over 20, and we will also bring down y, and the exponent will become positive 3 over 4. And finally, we are done with simplifying this expression. We have completed section 11.2, and this section is fractional exponents. Thank you.